and welcome everybody. BatAbility Club is out of this world. I've been looking forward to saying that for about the last week and a half when I thought about it. So apparently, yes, we are out of this world. We are going to be looking at astronomy and astrophotography during this exclusive to BatAbility Club members session with the marvelous, the wonderful, the over the moon to be here. Al Milano, how are you doing today?
Very good, thank you.
Yeah, you're looking forward to this, yeah?
Yes.
Yeah, and this all happened because of John P, okay, saying, hey, Al's into astronomy. By any chance, could we get Al doing something on astronomy on Club? And I thought, that's totally bonkers. Why would we do that, you know? And then after about 5 seconds of me being negative about it, I thought, why wouldn't we do it? Why would we not do it? No, it's winter. Bat workers are bored. Yeah, let's give them something else to talk about. So John P, I know you're actually listening live, John. Thank you. That's an amazing suggestion. Okay, amazing suggestion. So thank you for that. Al, are you ready to share your screen? If you just give me 2 seconds, I've just got to do something here that will allow you to share. Right, you should be able to share now. And Al, I'm going to kind of say something here. I haven't got a flipping clue about this subject at all. So I ain't going to be able to come up with any, not that I usually come up with sensible questions, but on this occasion, I can guarantee that I do not think I'm going to come up with any sensible questions whatsoever. Okay, other than how big is your scope? That's probably about as technical as I'm going to get.
I'm hoping, I'm open to any questions at all, because just in case, I didn't cover possibly something. So I definitely encourage questions.
Well, I'll think the silly questions. What I did say was I'm not going to be able to come up with any sensible questions. That doesn't mean I won't come up with any questions. But yeah, no, it's going to be fun. It's going to be fun. Apart from the fact that I'm sitting here with a sore back. Now and again, I might stand up, okay, just to give myself a stretch, but that's all. Are you managing to share the screen?
Yeah, just about. Let's see.
Okay, no, that's cool. I was just making sure that I'd done everything I'd intended to do. Yeah, here we go. Looking good.
You can hear me?
I can hear you, and I can see your introductory slide. Yeah. So, how long do you think you're going to be, Al, just roughly talking?
Yeah, about an hour or less.
Okay, sounds good. Just so I've got a rough idea.
Possibly just shy of an hour, maybe.
Okay.
Or maybe less.
Sounds good. Right, everyone. Here we go. Right, ready for liftoff. I'm passing you over to Al Milano to talk about an introduction to astronomy and astrophotography.
Thank you. Okay, so I'm kind of going by the presupposition that folks don't know possibly too much about astronomy, so I want to do a quick introduction to astronomy. So it's estimated that there are between 300,000 to 1.5 million amateur astronomers in English-speaking countries. And that's 1% of the UK population, based on 72 million people living in the British Isles. And at the same time, some estimates state that there are 3.4 million amateur astronomers worldwide. So amateur astronomy, basically, kind of like this is the kind of the Wikipedia, Cliff Notes version of the Wikipedia definition. It's a hobby where people enjoy just observing or imaging celestial objects in the sky, in the night sky, using either the unaided eye, binoculars, or a telescope. And luckily, I know that you've all looked through binoculars before, so that's the easy part. I know that just about everyone in attendance here has looked through a pair of binoculars and possibly even a couple of spotting scopes. And I definitely bet that you probably each own a pair of binoculars, because folks who love bats and folks who study bats usually like birds as well. Many of them are birders. I am, Neil is, there's others. So that's a good start. So you're all minutes away from being amateur astronomers yourselves. All you need to do on the next clear night is just step outside your door with a pair of binoculars and get a printed star chart, of which there are about a dozen different places online where you can just Google free star charts. Print out a star chart of an area of sky you'd want to look at, a constellation you want to look at, and just look up and observe a couple of objects. Look around. Wherever there aren't trees or buildings blocking your view, that kind of narrows it down sometimes. I, in fact, have done, astronomy very much the same way many times, just stepping outside of the door and just, with a pair of binoculars, depending on whether they can be handheld binoculars or mounted binoculars on a tripod. So generally speaking, amateur astronomy is looking up at the night sky. You can learn a few constellations. That's easy to do. And you can, if you kind of want to get into astronomy, eventually you'll choose a type of object that interests you, whether it be open star clusters, planets. Some people love planets. I don't usually go too crazy for planets myself, but galaxies, nebulae, which is the plural of nebula, globular clusters, which are tightly knit, kind of compressed clusters of stars, open clusters, which are very easy to spot and look at in a pair of binoculars. In fact, it's highly recommended. Some people love double stars, and some people love carbon stars, but all in all, of course, you can say that there are plenty of objects to choose from in the night sky, and ones that you would might find especially interesting. So we're talking about optics. Believe it or not, binoculars are always the most commonly recommended instrument to beginners to get their first taste of astronomy. So if you pick up probably about a dozen books for beginners on astronomy, and in just about all of them, they will recommend that a beginner just grab a pair of binoculars, wherever they may be. If you don't have a pair of binoculars, you can buy a very inexpensive pair of binoculars for as much as $25 US, and even those will suffice if you don't have a pair of binoculars. And some people actually stay with binoculars, myself included. I actually prefer using large binoculars to do astronomy and to sketch deep sky objects. Now, as I said before, many of you have binoculars. And as experiments, I've also tried what would be considered less than ideal binoculars, which would be birding binoculars. I even have a pair of those butterfly binoculars made by Pentax. They make two models of those. They're very small. And just in a pinch, and just out of curiosity, I've used those sometimes, just walk outside with these little tiny 8x21 binoculars. And, they allow you to get a view. They're better than nothing at all. And it's interesting. So as I said, I'm very fond of using binoculars for astronomy. And there are several very excellent books on the subject of binocular astronomy. And there are a couple of websites, as you might imagine, also dedicated to people who enjoy binocular astronomy. And it's, two eyes are better than one, but not just for the obvious reasons. When you begin to read a lot about binocular astronomy, for example, there are a lot of subtle things happening in the background. There are a lot of things happening in the brain which improve the view uh, through binoculars. They really improve the view, the ability to see color better, and just a lot of nuances which you wouldn't probably expect until you started to look into why binoculars are really good. So other instruments. One of the things that are kind of popular these days are what they call constellation binoculars, and they're generally around 2.1 power, and there were probably about 5 manufacturers making them now. And they generally run about $200 US, and they're kind of strange if you see them. They look like almost like spectacles on steroids or something. And what they're designed for, as the name implies, is so that you can see very large areas of sky, and you can fit an entire constellation most times. So an entire constellation of stars in the field of view of these constellation binoculars. So I thought I'd just mention. And of course, binoculars, handheld or tripod mounted. And then we have telescopes. So the simple refractor is what people normally, who don't know anything about astronomy, would describe as the long, skinny telescope. Then you have Newtonian reflectors, which are, the fatter telescope, which uses a mirror. A Dobsonian, which is probably one of the most highly recommended for beginners, especially, as they say, a bang for your buck. You can't go wrong with a Dobsonian because you get a large aperture telescope for comparatively little money. Schmidt-Cassegrain are the very short, very stout and fat telescopes, and also Maxitovs. And those are known as SCTs and Max. So SCTs and Max, they call them Max for short, Maxitovs, named after the scientist who invented it. So we could look at some of the pros and cons of the hobby of amateur astronomy. It's easily accessible. It's mainstream and popular. And a major magazine is printed monthly, sometimes bi-monthly, in almost every country, and devoted to the subject of astronomy. And there are several others available online, and several now these days are dealing specifically with astrophotography. And there is, I believe, one free online magazine devoted to astrophotography. It's kind of loaded with a lot of advertisements, but that's one of the things that are out there. And astronomy clubs exist in every major city. The cons would be it's weather dependent. You can't enjoy astronomy without clear skies. It would be ideal if you lived under dark skies, but the countermeasures exist, which are light pollution filters. They make some very fascinating filters, glass filters, which are a whole, subject and presentation into itself. But they will darken the sky for you. They will block out light pollution and allow only the spectrums of desired light through. And so the desired light from nebulae and other deep sky objects. So the initial investment can sometimes be substantial, but you can get a very nice telescope for about 300, I'll say 300 pounds sterling. And that would be a nice one. And if you wish to get into astrophotography and start capturing images, Anything beyond attaching your cell phone to the eyepiece of either a pair of binoculars, and that's been done before, or attaching your cell phone to the eyepiece of a telescope with a very inexpensive little device that holds your cell phone in place. And you can take snapshots of the things that you're seeing, you know, at the eyepiece of your telescope. So that's fun and easy and inexpensive. But anything beyond that, the investment in money and time increases. Here are some types of telescopes. Amateur astronomy hobby. The one on the left is a Newtonian, tripod-mounted Newtonian reflector. The next one, that dark silhouette, is a Schmidt-Cassegrain telescope. The one after that is a classic refractor. That looks more like a vintage refractor, but they do make modern examples of that telescope as well. And the last one is another reflector, Newtonian reflector. Now, the interesting thing is, you know, choosing a telescope, you'd want to kind of, well, first I'll say that a Dobsonian reflector is considered the best all-arounder. So that's considered the best all-around telescope. But if one were to focus or have a particular interest in some particular deep sky objects, then each one of these types of telescopes excels in viewing those particular objects. So if you were really into, oh, go ahead. I'm sorry, Neil. Go ahead.
No, it's okay. You didn't have to stop right at that moment, but I'll ask a really stupid question here, okay?
Yeah.
Right, so each of these scopes appear to have a smaller scope attached to them.
Yes.
What's that all about, just in case anybody doesn't know? Yeah.
Oh, yeah, that's the finder scope. Those little scopes are the classic smaller little, typically 6x30 in size. If you're lucky, it's 8x50, which is more desirable and easier to use. And what it does is there are crosshairs in it, and it allows you to, once it's aligned with the main telescope, which is a short little procedure, it allows you to locate the object of interest that you want to view in the main telescope. And so you locate it using the little small finder scope, and then you can view the object in the larger telescope.
Right, because otherwise the larger scope has got so much magnification that you'd be kind of going backwards and forwards, and you wouldn't be certain that you were looking at the right bit. Is that the idea, is it? Yeah.
Yes. Without the finder scope, things would be quite difficult.
Okay.
Yeah, unless, of course, if you could use a spotting scope. So many folks have spotting scopes, and of course, spotting scopes have such a wide field of view that they don't really require any kind of finder scope. But as you said, in the case of real telescopes, their field of view is more narrow, so you need a finder scope. And they also have, which are very popular, what they call reflex sights, which are kind of like a little tiny heads-up display it projects a red circle onto a small piece of glass, a tiny plate of glass, and it allows you to superimpose that reticle, that red reticle crosshairs onto the object of interest, and then the scope will be considering it's aligned, the scope will be then trained on that object. So you would use it's called a Telrad sight, is the most popular manufacturer. It's a Telrad sight. It's fairly inexpensive and easily attached. They come with double-sided tape. You just place it on the telescope. In the case that for whatever reason your telescope doesn't have one of these little finder scopes, well, the Telrad sight, some people actually prefer it. A lot of people actually remove this little finder scope and put a Telrad sight in its place because of the ease of use. Yeah, it projects a red circle, which is it varies in brightness. You can adjust the brightness as well.
Okay, sounds good. Right, keep going. Okay,
Okay,
there
so
are some questions out there, but we'll
oh
leave them
yes,
till the end. Okay, yeah,
yes.
keep going. Cheers.
So the a reflector such as Newtonian reflector on the far left would be very good for deep sky objects. The Schmidt-Cassegrain, which is the next one, is also considered by many to be a good all-rounder scope, but it excels in looking at planets and smaller deep sky objects. But again, it's considered an all-rounder. The next one is the white refractor, and that one is best suited for planets. That would be the type of telescope that someone who's a planet aficionado would go for, because they really excel at viewing planets. And then the next one is another Newtonian reflector, which is also a very good all-rounder, and it excels at viewing deep sky objects. And these are like some generic types here, just to give you an idea. Now, getting into astrophotography, I thought I'd show, I've always looked at trying to, with astrophotography, doing it on a low budget, because over the years, people will have said that you need to invest, that you need to invest about $2,000 to $3,000 in order to do astrophotography properly. And that's actually not the case. I've been able to do it for under $600 from starting from zero, starting from scratch. And here's an example. This is what's known as, this is an old-fashioned, as you can see, it's made out of plywood. This is an old-fashioned barn door tracker. It's called a barn door tracker. And it's very simple, but it's effective. And you can make them yourself if you're very handy. There are plenty of free DIY plans downloadable off the web. This particular one, I'm not that handy, so this particular one I purchased off of another hobbyist for like $25 US. It has a small 12-volt stepper motor. A small circuit board is housed inside that white box, that white plastic box. And then there's the long curved bolt, which allows it to, basically what all this does is allow your camera to track the stars. It allows your camera to compensate for the movement, for the Earth's rotation. So it helps compensate for the Earth's rotation, and allows you to capture pinpoint stars instead of star trails. So basically, this enables you to take astrophotos. It enables you to take photos of deep sky objects, especially extended deep sky objects, which would be larger deep sky objects. So as you can see, this is on a tripod with a ball head mount. Okay, so altogether, this is not much of an investment here. This is the least expensive way to get into astrophotography. Then there's another ball head mount attached on the top of that, and that is where you would attach your camera, ideally a DSLR. So there's a little bit of a learning curve, but not much using this kind of setup. But you would attach a DSLR on top of that, and you can be off and running and doing a bit of astrophotography. And this is a way that you can actually learn to begin to do what they call wide field astrophotography. So you're taking images of large swaths of sky. And I just wanted to show that. And these are the results that I've been able to get with a modified Canon DSLR is what I had. And that's what's the most popular camera for modification. Nikon is another one as well. There are places that do the modification for you. You can send your DSLR away for about, I'd say, 300 pounds sterling. and have it then modified professionally and returned to you. And what the modification does is it increases the sensitivity to hydrogen alpha light, which is what we're seeing here. On the right-hand side, this is one of the better images. This is the California Nebula. And that red is hydrogen alpha atoms being irradiated by the nearby star. But I don't want to get too crazy technical or anything like that. But the modification to a DSLR is what allows you then to capture that nice red color, red of nebulae in the sky. And the one on the right here is the California Nebula. Excuse me. And on the left is another wide-angle shot, also taken using that Bondor tracker and modified DSLR. And you can see some faint nebulosity, two large patches, one in the center, which is actually the common name is the Heart Nebula, and just below that is another patch of red nebulosity called the Soul Nebula. So that's the Heart and Soul Nebula, and some trees there in the back and on the sides. And right up in the upper right-hand corner is the double cluster in Perseus. So in the constellation Perseus, actually not far from the constellation Cassiopeia, is the double cluster. And as you can see, it's two clusters of stars very close to each other. And it's a highly recommended object for any instrument to look at. So with a pair of binoculars, you should put that probably near the top of your list of objects to look at. So with just about any pair of binoculars, go out on a clear night and look for the double cluster, which is not very far from Cassiopeia, very easy to find, and it just looks amazing. So I don't know, you could just about see those two nebulas. They're large nebulae. Again, the Heart and Soul Nebula in the middle of that. That's simple and cheap. Now this is when you get really serious into astrophotography. This is this type of kit and setup would easily cost between $4,000 and $5,000 US. This has all the bells and whistles, all the great complicated stuff, which is I actually find very interesting and fun. I just can't really afford it too well, but so we'll get to that whole subject when we talk about smart telescopes. But I definitely wanted to show this. These are all like high-end devices. We have a guide scope on top. We have the white refractor telescope acquiring the main images. We have a filter wheel. This is a device that rotates special expensive filters for you automatically, controlled by software. It's just amazing stuff. That large black thing at the end that looks kind of like a soup can, that is a multi-$1,000 CCD camera. It's a cooled CCD camera. It uses high technology to keep the camera cool. Then that blue box is a computer that controls everything, and it's also has a go-to ability, so you can tell it what object you'd like to view and punch it into the hand controller, and the entire thing will slew. It's called slewing, meaning the telescope moves to the object, slowly moves to the object you want to see, and there it is. But again, this is premium stuff and expensive stuff. They're pretty expensive. So here's where smart telescopes come in. This is the Dwarf 2. On the left is how it arrives, a little unpacking. I got it directly, ordered it directly from China, from Dwarf Labs. And as a bit of unpacking in the photo on the right, it's about the size of a large, and this is the funny part, it's about the size of a large dictionary. It's pretty insane, that it's a telescope, that is about the size, of a large book. And It's all automated. It's easy to use, and it basically does not only this smart telescope, but the C-Star S50, which we'll discuss as well. They basically do everything that this setup does, and that's like the crazy part. It does everything that this expensive setup does. It's all contained in this small package. It comes with this tiny, cute little tripod. It comes with a memory card. It comes with, this is the deluxe version, so it comes with 2 batteries. That is the battery on the upper right-hand corner, still in its packaging. And it gets placed on, it gets screwed right on top of that small tripod. And, you know, with a very minimal amount of setup, it's imaging controlled by your smartphone. And here are some images. Here are some results from that Dwarf 2. The largest photo here is known as M31, the Andromeda Galaxy. And this was done in under 30 minutes of exposure time, which is also amazing. And you can even see the companion galaxies, which are right above it, and there's a small round one just below it. Those are its companion galaxies, which I can't remember the numbers right now, but the main one is M31. And over on the upper right-hand corner, we have the Trifid Nebula. And you can just see a little bit of blue on top of the reddish region. It's called the Trifid Nebula because of it being seemingly split into three parts. So it kind of has those divisions that makes it look like. And it's really a beautiful deep sky object. And that was also done with the Dwarf 2. The one below it is the Veil Nebula. There's an eastern and a western side. This is the eastern side. I get confused. This is the eastern side and the western side of the Veil Nebula. You can usually only capture one at a time because they won't fit in the field of view. But one of the strong points, for example, of the Dwarf 2 is that you can fit large deep sky objects, such as the Andromeda Galaxy and the Veil Nebula, comfortably in the field of view. So as you can see, the entire Veil Nebula, Eastern Veil Nebula, yeah, this is the Eastern Veil Nebula, you know, is well framed using the Dwarf 2. So here are some specs on the Dwarf 2. It only weighs 1 kilogram. It's super compact. It's controlled by either a smartphone or tablet, either Android or iPhone. It has go-to ability, which is similar to when we were looking at the traditional rig, the ability to go to any object, any deep sky object in the sky. And once it gets to that object, it tracks it. So it automatically tracks it so that you don't get any star trailing, which again is kind of like why we use the old barn door tracker. That's to avoid star trailing. So that's taken care of as well. And it automatically stacks the images for you. Now, that's something that you would normally be doing yourself if you were using the traditional big complicated rig, is you would have to acquire light frames, dark frames, bias frames, and flat frames, and then put them all in folders on your laptop, and then later combine them and stack them. I didn't want to get too technical or into it, but that's something that kind of like a major thing that is no longer required with a smart telescope. It has the ability to do daytime photography. You can also take photos of the sun with either of these smart telescopes. They are each provided with a very special sun filter. So you can take photos of the sun. I haven't done it yet because honestly, I'm not a big fan of it. I'm not a big fan of the sun or planets. I happen to love deep sky objects. So. But you can do that. And in addition, the Dwarf 2 is very good at tracking wildlife. So I've tested it where you can take photos or videos of birds. So you can have it out wherever you may be, in the back garden, on a deck, you can see a bird that happens to be hanging around in your back garden, and train that camera onto the bird, and it will follow it. This will also would also be good for waterfowl, ducks, or ducks or geese on a lake, and it will actually track the bird, which is interesting. And you can also take panoramic images, large vistas. It includes a rechargeable battery or two rechargeable batteries if you get the deluxe, and it comes with that 64 gigabyte Samsung. It's a high quality SD card. Some more technical specs. It has a very good resolution of 8.46 megapixels. It has a pixel size of 1.45 micrometers. A 24 millimeter lens aperture, which isn't very large at all. It's a small lens, okay? But it's amazing what it can do. But I should remind you that there are people doing astrophotography with their cell phones. So we all know cell phone cameras have very small lenses. So it's a 100 millimeter focal length. It's actually a refractor. The type of telescope it actually is, when you come down to it, it's a refractor. And it has a Sony IMX415 sensor chip. So with the Dwarf 2, it actually gives you, for lack of a better word, it gives you a taste of astrophotography, of real astrophotography, because you can manipulate things, you can stack your own images, you can take your own darks, your own dark frames, you can take your own flat frames if you were so inclined. Some people have been doing it, especially if someone has experience in astrophotography. They'll want to experiment with that, and you can do it with the Dwarf 2. And the thing about it is all the annoying factors have been omitted, such as stacking, organizing all of the files onto file folders on your PC. All of these things which are labor intensive. The other smart telescopes tend to get expensive. So if we're not talking about the Dwarf 2 or the C-Star S50, then every other smart telescope is considerably more expensive. 3 times, 4 times the price of these, and these range about $500 US. The other smart telescopes are completely automated, so there's no experimenting, there's no playing at astrophotographer kind of thing which you can do with the Dwarf 2, for example. And that's something interesting to consider. Now, these are relatively new. Until about 2 years ago, astrophotography was expensive, and it had a steep learning curve. Smart telescopes have been out, but for a few years, probably a little over 2 to 3 years. But the models that were available were very expensive. Again, about $3,000, about $3,000 US. So now we have these affordable ones, and that's a big difference. So the Dwarf 2 is the smallest and lightest of all the smart telescopes currently available. It's the most budget friendly by a small margin. It's $459, and directly from their website, and the C-Star S50 is $499 directly from their website. And it is a user-friendly, kind of like an entry-level introduction to astrophotography, because again, it allows you to manipulate a few things. It allows you to tinker a bit. So it allows you to, like if someone had previous knowledge of astrophotography, they would be able to bring that to bear with the Dwarf 2. You can use the bit of knowledge that you already have. And it's in stock all over the place, as well as Amazon. And yeah, okay, sorry, there's a slightly different, still it has some astrophotography aspects still are accessible to the user. And so now we get to the C-Star S50. And here it is in its case. When you open its case, this is what you see: a small, very high quality tripod. The C-Star S50 is made by ZWO, which is also a company in China, but they are very experienced in astrophotography. They produce and sell the lion's share of astrophotography equipment. There's probably almost no one doing astrophotography in the traditional manner without some piece of ZWO's equipment. So they would be like the Pedersen of astrophotography, you know, or another, you know, very popular brand. And the photo on the right shows it just placed on the tripod. The tripod legs have not been extended, but they do extend a little bit. They extend again another length, about another 6 inches from what you can see there, and that is the extent to which they expand. So it doesn't sit very high, and you can get a better look at the carry case, which is included on the left. It's a very light, made out of a type of foam, but it's sturdy and, you know, a good case just overall in general. And so it's developed by, again, ZWO. They're a leader in astrophotography equipment and have been for several years. So it's budget friendly still, $499 US. It's very user friendly. It's a very good user-friendly introduction to astrophotography. And I would describe its operation as completely automated. There's not much a user needs to do besides turn it on, place it outside in the back garden and turn it on, and then control it from your smartphone. It's also small and compact. It's controlled by either a smartphone or tablet. It has a very robust, really nice software that controls it. It has a complete like planetarium style software app, which gives you access to the entire sky. I think it makes it very intuitive to use. Of course, it also has object go-to ability and automatic star tracking, which are necessities with smart telescopes. And it also has the ability to do daytime photography and video. And you can take photos of the sun. Again, let's not forget that. Comes with a built-in rechargeable battery. And the memory for the storage of the photos is built in. It's not removable, and it's 64 gigabytes in size. Some more technical specifications. It has a resolution of only 2.1 megapixels, but despite that, it produces very nice images. Pixel size of 2.9 micrometers, a 50 millimeter apochromatic lens aperture. Many of you know what an apochromatic lens is. It's a lens that brings all colors, generally speaking, all colors of light to focus, whereas an achromat does not, only brings two out of the three main spectrums of light to focus. It's f5 in speed, focal ratio, and it's 250 millimeters in focal length. So it's a 250 millimeter refractor housed in this black plastic housing. It uses a Sony IMX 462 chip, and it's 6 kilograms in weight. And it basically only requires a flat surface to give you an introduction to astrophotography. So a flat surface being a table, something like that. And here are the results of of the images from the C-star S50. On the left is a planetary nebula called M27, Messier 27. It's the remnants of an exploded star, a star that exploded. And the interesting thing here is it's only 9 minutes of exposure time. That image was captured in 9 minutes, 9 minutes of time. It's been post-processed by me a little bit using just the built-in app on my iPhone. Just did a little cleaning up. That's what I do on many of these images, just for the sake of doing it quickly and easily and for convenience. I just do a little bit of post-processing right on the iPhone or tablet, and you get results such as these. To the right is M13, considered the largest and most spectacular of globular clusters. It's a globular cluster of over 100,000 stars compacted in a compact looking ball. And again, it's M13, Messier 13, and this image was acquired in 4 minutes. This is 4 minutes of exposure, just letting the C-star do its thing. Here we have on the left, this is known as Caroline's Rose, because it was named after William Herschel's sister, Caroline. William Herschel, of course, being a very famous astronomer. This image was captured in 21 minutes. It's known as NGC 7789. That's his formal designation. On the right, we have what's known commonly as the Pac-Man Nebula. This is NGC 281. And this image was acquired in 15 minutes. So it takes 10-second images and stacks them one on top of the other and aligns them and gives you this result. It stacks the images for you, and the images are ready to just, like I said, you can do just a little post-processing, a little cleaning up, as I say, and then they're ready to send via, social media to your friends and family. It's neat. I do it with both of these smart telescopes. And this is the Rosette Nebula. This is known as the Rosette Nebula, also known as Caldwell 50. And this is a large emission nebula, and quite easy to find. It's not far from the constellation Orion. And this was acquired in 11 minutes. And I believe with this one, I did a little more extensive post-processing. But as you can see, it really looks really good. I like it. So you wonder which one for what? The Dwarf 2 is best suited for large deep sky objects. So if you happen to like large deep sky objects like the North American Nebula, happens to be a large nebula that looks like a profile of the North American continent. And there are some people who really like large deep sky objects. So this would be the best scope for that. And it also seems to do a little bit better when tracking wildlife, basically when tracking birds, tracking songbirds while taking videos of them. And the C-star S50 is better for smaller deep sky objects. And I prefer to go after planetary nebula in my case, and those are typically small objects, and the C-star S50 is well suited for that. And it also produces slightly nicer astrophotography images on the whole. I mean, that's debatable, I guess. But both of these smart telescopes are basically changing astrophotography forever. And this is just a recent thing. And I think that because they're so, especially one of the key things is the fact that they're so affordable. Because when looking at the large conventional astrophotography rig, just one of those components, one of the lower cost components of that ensemble can cost $500. So that's something to keep in mind. And all of the stuff is on my blog, of course. I have slightly more detailed reviews of both of these smart telescopes on my astronomy blog, my urban astronomy blog. And that's what I have for slides. But any questions? I don't know.
Oh yes. Oh yes. I didn't think I'd have any questions at the end of this, but I think I've actually got some good questions, right? But before I ask any of my questions, John P is asking a question, and you can probably recommend a few, but can you recommend a website for good downloadable star charts, please? Is there one website that you can recommend?
Yes, there's, if you Google free star charts. So if you Google free star charts, there's actually a site that's called.
And I'm going to ask a stupid question. I'm going to ask a stupid question.
No. Yeah.
Will that produce star charts based on where you are in the world? Because if you're in North America compared to being in New Zealand, for argument's sake, things look a little bit different, don't they? Or do they?
Yes. South of the equator, things change.
Yeah.
Things change south of the equator.
Okay.
But for all of us north of the equator, we're good. we can go. And what happens is there are a little bit fewer resources especially as far as free star charts and free things such as star charts and things like that. They're a little less available on the web if you happen to live south of the equator. But for us, north of the equator, there are just loads of free resources for those of us who live north of the equator.
And what about introductory books? Is there any? And hey, folks, let's be absolutely one thing that's going to be absolutely certain here. Okay, Middleton is never going to write a book about astronomy. That's not going to happen. But John's asking any recommended books, please.
Yeah. One of the top recommended books, one of the few, let's see if I can think of more than one, but probably the top recommended book is one called Turn Left at Orion.
Turn Left at Orion. Okay.
Yeah. And that is probably one of the most commonly recommended books. But there are, as you would imagine, there are several. I happen to have a large collection of books on the subject of binocular astronomy, and in fact, there are, of course, some of the most excellent authors of astronomy books are on your side of the pond. They're your countrymen. Okay. They have the best. I prefer them, in fact, many times over American authors. So that's something else I wanted to mention. But yes, there are, you can Google binocular astronomy and you will find an excellent site on binocular astronomy as well, by an author who I like. I believe his name is Alan Moore, and he's in the UK. But again, you can Google stuff like that, and there are planispheres. These you can get these. This was like a free one, and you may not be familiar with these, but this is like just a little free one. And I'm sorry for some reason.
That's okay. We're getting in focused down again. That's good. Yeah.
You put the date and time on this wheel, and then it tells you what's visible in the night sky. And this light blue swath over here is the Milky Way. That represents the Milky Way, which, depending on your sky brightness, you'll be able to see or not. But you can buy a good quality one of these for just a few bucks on Amazon. And it's so old-fashioned, but I love them.
Okay.
I like them because you could just sit there anywhere and doesn't require electricity. I don't know.
Okay.
Yeah. But yeah.
Right, for that website and that book that you've talked about, I'll try and find links for those and look underneath the webinar in the show notes on the club
Yes,
portal
yes.
if you want.
And
Fingers crossed, I'll be able to provide those links.
yeah,
Okay.
I'm sorry, I just so happen to be discussing in my last two posts on my astronomy blog.
Yeah.
Have been all about books,
Okay.
including links. So
okay,
yeah,
I'll
I recently,
obviously put a link to your astronomy blog as well. Okay.
my last two posts were
Yeah.
all about books. So
Yeah, okay. I'll put a link underneath the show note with the show notes for that. Right. Okay. Here's some quick hit questions. Okay. Let's start with down to earth. You've got the Dwarf 2. It's tracking a small bird, right? That you've asked it to track.
yeah.
That bird then flies away, say 100 meters to the left. Does the telescope actually track it as fast as it's flying? Or at that point, do you lose it? Is it just tracking it if it remains?
you would lose it if a bird were to decide I'm going to fly even 50 meters to the left.
Yeah.
I'm going to go 50 meters to the left. The bird decides.
Yeah.
The telescope loses it.
Okay. But if the bird's just moving about within a tree.
Yes.
Okay.
If it's moving about in a tree, or commonly, the way I've used it, the birds have been just flitting about on the ground, hopping about on the ground, looking for insects. It will track that bird as it's looking for insects.
What about you've got a raptor soaring over in the sky? Probably not.
Not as easy. No,
Okay.
not as easily done. You'll probably end with frustration. That would probably end with frustration.
Okay. Right. Next question. Getting a little bit higher up into the sky now. What about things like tracking satellites, space stations, Elon Musk's latest rocket venture, stuff like that? Is that possible, or is that stuff just too close?
A lot of people would like to do that. People ask on all the forums on almost weekly basis. They may be working on employing that feature with the software that comes out. So they have software updates, and which one of the smart telescopes will come out with that ability first remains to be seen. But they are both aware that there are people who are very interested in regular man-made satellites and Starlink and things like that, and the International Space Station. And they would love to be able to track them. And so currently, no, neither one will really do it. But they're well aware because they get that request. They get that request a lot. And so I'll just add that Dwarf 2 comes out with updates and firmware updates and software updates more infrequently than C-Star. So the C-Star S50 comes out with more frequently. They come out with neat little updates to both software and firmware, and they just came out with one recently.
But if you had one of these instruments, or if you had a more traditional telescope, you would be able to focus that telescope on the space station if you knew where it was. Is that correct, or is that a waste of time?
Yes, you could. Yes, with a conventional telescope and one with you would disable any kind of tracking on it, and you'd be able to follow it with a wide field eyepiece inserted. You'd be able to follow it using your hand on the control. So many telescopes, even the ones that are motorized, you can shut off the motor and turn off the motor and use the hand control, turning the hand control with your fingers, so you're turning the hand control with your fingers like this and tracking the satellite. Probably do it a little quicker than that. But you'd be able to track the satellite if it has something like the arm that usually comes out of a fluid head on a tripod. Sometimes, you could put a refractor, a small refractor, a wide field refractor, very inexpensive, on a tripod, and with that tripod fluid head, just easily follow and take a good look at International Space Station, for example, or even a satellite. Binoculars are very good for that as well.
Okay. What about looking at something like the moon and things like Mars, Saturn, Jupiter, which I know this isn't your bag, but
Yeah, that's
but I
okay.
would imagine a lot of people getting into this. I don't know, the first thing they're going to want to look at is kind of see craters on the moon, for argument's sake, you know?
Yes, yes,
Yeah.
yes. Okay, craters on the moon, that's the good news.
Okay.
Either one of these telescopes will show you craters on the moon, will give you actually, you can take some nice photos of the
Yeah.
moon with either one of these telescopes.
Okay.
The planets, not so much, not yet, but there also is a race between them to see which one of the companies is going to come out with that ability first. So they're both actively working on you know giving that ability to their customers
Okay.
who own their telescopes. But who will do it first remains to be seen. So
Okay.
in other words, as it stands now, no, you can't take any good images of planets.
Okay. But if you were, let's just say you took the Dwarf 2 or the other one, the Sea Star S50, would you be able to get Saturn with its rings? Would you be able to get?
No, you'd be able to see currently. You'd be able to see that's you. People have tried, right? And
Okay.
you see a small round sphere with two lobes sticking
Okay.
out of it.
Okay.
So of course those are the rings, but that is the extent of what you'll see. You won't see the nice, the rings and things.
But with one of those more traditional, more expensive telescopes, would you get that? Yeah.
Yes.
Okay. Okay.
Oh yes.
Right. So what I'm imagining happens here then, if you're looking at something like the Dwarf 2 Sea Star S50, these are kind of set up in a way whereby I would imagine the fact that they're tracking the long exposures, the stacking, etc. This is all, as you would describe it, aimed at stuff that is much further away than planets, and it's not
Yeah.
really as suitable for things that are closer to us. Is that a
Yes.
is that a
Yes.
fair way to describe it at the moment? Yeah.
Yes.
Okay.
Yes. Deep sky objects. They're
Okay.
both excel at deep sky objects.
Okay. But not as good at nearer objects than a traditional telescope.
Right. Right.
Yeah.
Right.
Okay. Okay. But obviously, traditional telescopes are a lot more expensive pound for pound, and they don't have all the fancy features that something like a Dwarf 2 has. Yeah.
Right.
Okay.
Right.
But you could take a traditional telescope. I mean, I've got one of these from a birding where there's an adapter that goes around my phone
Oh
and it
yeah.
fits over the eyepiece of the scope, and it
Yes.
allows you to take photographs through the scope. I'm assuming when you were talking earlier about people doing this in astronomy, it's exactly the same kind of adapters you would use for digiscoping birds and stuff. Is that right? Yeah. 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 Okay.
Yes.
Yeah.
Yes, you
Okay.
can do that. And so you can do that. And the thing is, for someone who happens to be interested in planets, all they would need to do is get just about any kind of traditional telescope would do, any of those types that I kind of showed earlier, and just attach the way you're describing, attach their cell phone and take 1 second images of Jupiter, Saturn, and they'll be kind of decent.
Okay.
Which is weird. It's weird to say that you can get a $200 telescope and get a $20 adapter,
Yeah.
a cell phone adapter, and attach your phone to it, and then get nice images of the moon, very nice images of the moon, in fact, and nice images of several of the larger planets.
Listen, I mean, I don't know if I want to say what kind of telescope I've got, okay, but it's a bloody expensive telescope, okay? It's
Okay.
top of the range birder telescope.
I know.
Okay.
I know.
Okay.
I know which one. Let me see. It begins with an S.
That's right. Okay, that's right. I bought it secondhand, folks. So I saved myself £1,000 by going secondhand. But that tells you how much it was actually. But if I was using that's Swarovski, right? And Aileen slags me off because I can't say Swarovski that well. Aileen, being a classic girl, right? She knows exactly how to say it because she's asked for their jewellery often enough. so she was well miffed off, but she didn't get any jewellery. But I came back with a flipping telescope. But anyway, if I was using that scope, right, with a 20 to 60 times zoom on it, I can't wait to try this. Is that going to look okay? Is that going to be?
Oh yeah.
Yeah.
Yeah, yeah. And just, start off with, set your phone to 1 second exposures.
Yeah.
It might be just a few milliseconds below 1 second exposures will probably be the most ideal, perfect, result. Will probably just shy of a full second of exposure. That would be my guess. But try 1 second exposure and you'll see.
Okay.
Yeah.
Okay.
Oh yeah, fun.
Can't wait. I can't wait for this. Right. Aileen does this thing from we're in France. We're very lucky. Where our house is there, there is hardly any noticeable artificial light. And she does this thing. I don't know what she does, but I know it's an app on her phone. And the app must tell her exactly where she is on the planet. And then she then points the phone up at the sky. And then as she moves the phone around, she can see on the phone the different stuff that we're looking at, right?
Yeah.
Have you got any recommended apps that do that? I don't know which one she uses. She just did it one night for a laugh, so to speak, because we're sitting outside and it was dark.
Yeah.
Yeah.
The one that's very popular is called Stellarium. That's very popular. Stellarium.
That sounds familiar. That might actually be the one she uses. Stellarium.
It's free and it's okay. And it's very popular. It's probably the most popular one, but probably one of the next ones because there are several. But one of the ones that I like and use is called Sky Safari.
Safari, okay.
Yeah, and I use that on my iPhone, but I believe they make it for Android as well.
Okay.
Sky Safari, I actually really like that one. And if you were to get into the traditional astrophotography, there's a way to have the Sky Safari software help control your telescope.
Right.
Like in the future, not like if someone were to buy a whole bunch of stuff and a rig like that and, put it all together and have the discretionary funds to do that. And then the Sky Safari software can, integrate with it as well. So that's as a side note, but I just happen to like it because it's very good. I think it's very good. Sky Safari.
Okay. Right. Last question.
Oh no, please.
No. This is genuinely the last question. I did have more, but as you went through, I was able to score certain things off. Sorry, 2 last questions. Easy one, first of all. You talked about the specifications for the Sea-Star S50 and the Dwarf 2, but you didn't mention in the specifications what sort of magnification they were using. Are these quite low magnifications?
Well, that's an interesting
or does it not work like that?
Kind of be. It would actually. There's a formula, and I don't know it off the top of my head, but there's a formula that will allow you to compute exactly and it's like a simple formula. It's really just very easy thing, but I just can't remember off the top of my head. But there's a way to figure out and multiply and figure out what the magnification is. But what it is that generally, I don't know, in astronomy, a lot of times what we're talking about are telescopes and then eyepieces. So what happens is you remove an eyepiece and put in another one.
And that changes the magnification.
Yes, right. And that changes the magnification. So that's why this is kind of like more of like an uncharted area where most people wouldn't sit and consider, although there have been, because the super nerds and geeks, of course they're going to wonder about that. I've never really wondered about it, and I don't know. It shows you. I go by the field of view that you're seeing, and so And I'm sorry, I can't say off the top of my head what the
No,
magnifications are.
that's okay.
But,
If you're looking at a bird through it,
oh, yes, right.
would it look noticeably closer to you on the screen
Oh, yes,
compared
yes.
to?
It'd
Yeah.
be the equivalent of like a 12x binocular.
Okay.
It
Okay.
would be,
Right. Yeah.
yeah,
Yeah.
like a 12x, maybe a 15x. That would be like the dwarf, and the sea star would be even a little closer, maybe like a 20x.
Okay.
If you use the
Okay.
sea star, yeah, about like a 20x, if I had to
Okay.
say. Yeah,
But these magnifications stay the same all the time. You don't adjust
yeah.
these
No,
magnifications. No. Okay.
no,
Okay.
no.
Right. Here's the very last question then, because this was going to be the last question, and then I realized I hadn't asked the one about the magnification. Just in very, very simple terms, okay? Make this Neil-proof here. You started off the presentation talking about clusters and nebula, right? A cluster, is that just a group of stars?
Yeah, well, there are two, like you could say, there are two main types of clusters.
Okay,
There are open
right.
clusters, and there are globular clusters. Now, the thing that defines a star cluster is it is a grouping of stars, and they could be an open star cluster is a loose grouping of stars,
Okay,
kind of
loose,
loose,
okay. Yeah,
and they stay in position throughout the night. So they'll stay here. The next night they'll be there. They'll still be the same.
okay,
They're immovable, like in space. Like in other words, they're almost like a bunch of friends that never part. That
okay.
that cluster is that cluster,
So
and
it
it'll be that way for
always looks the same, basically.
yeah,
Yeah,
for 5 billion years. It'll just stay like that. In that. It'll always look the same, in other words,
yeah.
and it
Okay,
moves, in the night sky, and it just always remains the same. It is that way deep in deep space, and that's the way
right,
it is. They don't move or anything. It looks the same now. It'll look the same in 5 billion years from now. And kind of the same thing with globular clusters. So globular clusters are very tight knit. As you had that one, the M13 is like our showpiece cluster in the northern hemisphere, and it's really something to see, even in any a decent telescope or even a spotting scope. And it's it looks like a uh, tightly compressed ball. In that case, of over 100,000 stars. In the case of M13, and that also is an object that is uh, way out in deep space, and remains the same. And the interesting thing about globular clusters is some of them are outside, or most of them are outside of our galaxy. They're
okay.
outside of our galaxy. They're completely outside of our galaxy. So when you look
So
at a globular
you're
cluster,
saying 100,000 stars. Okay, this is
yes,
just kind of what blows my mind here.
yeah,
That is like 100,000 equivalents of our sun. Is that right?
yes, except they make our sun, they're usually generally much larger than our sun, and a
Right.
lot of them are more interesting than our
Yeah.
sun.
And each
Yeah.
of these stars has the potential to have planets associated with it. Is that correct?
Yes,
That's
yes.
just crazy. That's
Yeah,
just
that's why
crazy.
I love looking at galaxies. Galaxies are just amazing because you're looking at another galaxy, and you
Yeah.
know, our Milky Way, and you're looking through it, and that's what the Milky Way is. When you see the Milky Way, you're looking at the edge. You're looking out at the edge of our galaxy, which
Right.
is the Milky Way. We call it the Milky Way.
Right. Okay. Okay. And very last question then, because this was going to be associated. You talked about the clusters. You've talked about the loose clusters and the globular clusters. What exactly is a nebula? Well, I mean, you did kind of describe that, but could you give it another bash just in simple terms?
Sure. It's
Can you
like
tell me exactly what a nebula is? Is
it's
that
like a natural neon sign,
right?
except light years in length.
Right.
The length of many of them can be measured, not in stars or miles. So it's measured in light years, nebula XYZ is 4 light years across. You know, that's how large
So
it is.
is that an
And
object as such? Is it like the deep space equivalent of artificial light? But obviously it's not artificial light, it's
right,
coming.
right. You know, that's what I kind of, when I try to explain them, or when I try to explain them to someone who's a complete novice in astronomy,
That's me.
uh, I'll say that what it is a lot of um, a lot of gases, a lot of very interesting gases like hydrogen gas, helium, and triply ionized oxygen gas, and all kinds of interesting gases in massive quantities, and they're being illuminated almost like a neon sign might be illuminated by usually by one or more stars. Generally, it's one star that's very close to it. So there's a star that's very close to it that is illuminating, that is putting out such unfathomable amounts of energy, of pure energy, that it is causing these incredible expanses of gas to light up, to illuminate. So just the energy to solar, like, well, I wouldn't say solar wind, because when you say solar, we're talking about our sun, but this the solar wind from that particular star, the incredible UV energy that's being produced, and depending on the star, different types of energy is just so incredible that it's causing these gases to glow the same way a neon sign glows, because it's being energized by a mains outlet, you know,
Okay.
and kind of like that, except it's incredibly massive, and there are different kinds. There are emission nebula, which are like the ones I just described, and then there's planetary nebula, which are my favorite, that's the remnants of a star which has exploded many millions or many billions of years ago, and what remains is a shell of gas. So what remains is a shell of gas, and it's glowing, and it's incredible colors. It's beautiful, and so those are two of the type
Okay.
of nebulas. You know.
Okay, that's brilliant. I mean, I know there is a lot more to this stuff than what you're saying,
Yeah,
okay,
yeah,
or I suspect there's a lot more to this stuff, but that's on the basis where we're all beginners here, or at least I'm a beginner here. Uh, Al, you know something? That's just been absolutely fascinating.
yeah. Thank you.
Um, so uh, if you look underneath the show notes, we'll have links for many of the things that Al's been talking about there. We'll also have Al's email address in case anybody wants to, because I know that he loves to get emails from people on this kind of stuff. Is that right, Al? You don't mind giving people
Absolutely.
yeah,
I'm prepared for any questions, and
yeah,
absolutely.
yeah. So yeah, absolutely amazing. So BatAbility Club, it's out of this world. Al, I'm over the moon that you've impressed us all, and you've told us all about what you've been talking about this evening. Yeah, if somebody had said to me 2 years ago we'd be doing a webinar on astronomy, I would have gone, "What?" I don't think. But hey, you know, I think it's been a lot of fun, and it's been really, really interesting, and it's fascinating how there's a little bit of a crossover in equipment between
Yes,
what we're using here on planet
yes,
Earth compared to what we're using for looking further
yes.
away. So yeah. So
You,
what
you
can I
never
do?
know. You know, a person might like it. You know,
Yeah,
an ecologist might go out, and I know you all have binoculars.
yeah. Well, look, I'm gonna
So
put that.
you,
Yeah, I'm gonna put my hands up. Okay, I started off an hour and a half ago thinking this is going to be interesting, but me personally, I don't see myself getting into it. I'm
yeah,
being totally honest, right?
right,
But
right,
then
right.
as you started talking about it, I'm thinking, I've got a flipping massive telescope I use for birding,
Yeah,
and I've got the phone adapter for the phone. Even if I don't want to take pictures, I'm thinking,
yeah,
I'm going to do this. I don't think I might just do it once or twice. I don't
right.
know, but I'm certainly going to give it a bash.
Yeah, yeah, yeah. And it's also nice that some people buy, well, many birders buy high quality optics, whether it's binoculars or spotting scopes for themselves, because of because of birding, because of the art of birding itself. And I know how birders can get crazy. I'm a bit of a birder myself, and I know you are also. And we know birders can get crazy about their binoculars. And so many times they'll have high quality binoculars. And guess what? If you point those at the night sky, images, the objects you're looking at will benefit. They will look amazing in high quality optics. And that's the other bonus,
Well, I'm definitely going to give this a bash. And I know that Aileen is already fascinated because she's got that app on her phone, which she regularly gets out when we're sitting at night when we're down there. And I find it quite fun because she'll tell me, look, there's Saturn, there's, I don't know, there's Venus, there's, and stuff like this. And yeah, it's, so I do kind of, I find it fascinating. She doesn't know what, she's like me, she doesn't know what she's talking about, but she's just fascinated by the fact that we're out there at night and we're seeing all of this stuff. And, so it's, it's good stuff. But what we'll do is next time we do that, I'll take the scope out and we can look at stuff through the scope as well, maybe.
Oh, and I should mention Sir Patrick Moore. I don't know, somebody in the audience might remember Sir Patrick Moore.
Oh, yeah. And to be fair, I think despite the fact that he tended to be on very late at night, so well beyond the bedtime of most children, on occasions when I was allowed to stay up late, we used to watch The Sky at Night with Patrick Moore. And that was fascinating. And of course, you BBC, and I, we're of an age. Yeah, go for it.
Yes, the BBC Sky at Night still exists as a website.
That's it. Okay, right. Okay, didn't know that. Yeah.
Sorry.
No, that's all good. Right. Okay, we're going to bring things to a close, folks. So, Al, if you say goodbye to our recording live audience, I'll then stop the recording. So, there, over to you, Al. Thank you very much. Yeah.
Clear skies. Thank you.